Hi, everybody. My name is Steve Hastings, and today I'm going to talk about integrating Databricks with Azure. Azure Databricks is the same Databricks that has been around for a while. However, now Microsoft has partnered with Databricks to bring a version of Databricks to the Azure cloud environment. And I have to say, I've been pretty impressed with the Azure Databricks for a number of reasons, but perhaps most important to me is its ability to integrate with the rest of the Azure ecosystem. And one way in which it really excels at integrating with Azure is in the ability for Azure Databricks to talk to different data stores in Azure. So this talk is going to be about that. And here's a quick outline of what I'm going to talk about. So first, I'm going to show how to use Databricks to connect to data stored in Azure SQL Server. When we get there, you'll see that this can also be used to talk to any SQL database that you can connect to via JDBC. Second, I'm going to talk about how to use Databricks to connect to Azure Cosmos Tv, Azure's NoSQL, managed NoSQL database. And third, I'm going to show how to use Databricks to connect to data in Azure Data Lake Store. Okay, so the first integration I want to talk about today is connecting to a SQL database. I have a managed Azure SQL Server database running currently in my subscription, and I'm going to be using that to demo this integration. But as you'll see later, really any database that you can connect to via JDBC could be used for this kind of integration. And that actually doesn't really matter if it's in the cloud or maybe you have an on-prem database that you want to connect to, as long as you can connect to it via JDBC and you have all the appropriate network and security stuff figured out, you can use this integration to connect to your SQL database. So here I've just got Management Studio open and I've connected to my Azure SQL instance, and there's a table in there called clicks, and it's just got some data here. So if we go to Databricks, I've got a notebook open, and there's some code in here already. So this code is actually pretty straightforward. You can pull it from the Spark website, just the docs for Spark. You can go to this URL and you can find it, JDBC to other databases, and it's got code samples for all the relevant languages. Here in my notebook, I'm going to demo two different languages, Python and then SQL. So the first one is Python. And if we go back to our notebook, you can see here, I'm going to create a data frame, and it's using the typical spark.read syntax, format JDBC, give it our JDBC URL, which I've already constructed here. It's a SQL Server, and fortunately for us, Databricks already has a SQL Server JDBC driver installed on it, so I didn't have to install that at all. And then I'm just pointing to the specific table that I care about in the database. So I can run that. And it shows that is created a data frame here. And I didn't have to specify any columns because it just pulled that from the database itself. So now what I could do is display some of this data, and it'll actually pull it, and here we go. And we've got our data. So that was pretty simple. Now I think I'm going to demo how to do this in SQL, because what we can do is actually create a Hive table, which people can then use later if they want. And as you can see from our JDBC URL, we included the an admin user password, and maybe we don't want to give that out to everybody, and we just want to create a Hive table that people could then utilize, but not necessarily have the password. So what we can do here is use SQL and typical Hive syntax. This also is documented over here on the Spark website. They are creating a temporary view, which would only last during your Spark session, but you could also create a table, which would be persistent. So here we've got the syntax, and we're going to run this command. Okay, so then we've created it, and if we then run another SQL command, we can actually select from this Hive table. So we'll say select star from azure.sql clicks, limit 5. And there we go. There's the data, and just using SQL against this Hive table. Now, like many Spark data sources, we can actually do interesting things like push down filters. So we'll put a filter in here and say where app equals 15. And so there we go. Again, we've got a bunch of data, and it's all where the app is 15. Now, if we explain this query, what it's going to give us is the query plan. And you can actually, if you read through this crazy string, you can actually push filters, and here we've got app is not null and app is equal to 15. Now, what this means is that Spark is actually, when it makes a query to the underlying SQL database, it's actually saying to the database, hey, give me data, but only give me data where app is 15. So it's actually going to make our network transfer more efficient, because we're not going to pull all of the data. Since we know we only want data where app equals 15, we can actually just tell the SQL database itself that, and then we'll only get that data back. Okay, so that's pretty much it for the integration of JDBC for SQL databases. And like I said, I've used a SQL Server instance here in Azure, but really anything that you create a JDBC URL for, you can connect to. And just one last thing I'll point out is if you go back to the Apache Spark documentation, you'll see, and you go to JDBC to other databases, then you'll see a whole bunch of options. And some of these are actually really important if you have an actual production table that has a lot of data in it. So for instance, you can actually specify the number of Spark partitions that you want that if you pull a data frame from your SQL database, you can actually specify how many partitions that data frame will have. And Spark will make, each partition will make a call to the SQL database, so you'll have parallel reads from that. And if you do this, if you use num partitions here, you're going to have to sort of manually specify what column you want to partition on, and some extra details which you can read about here. Okay, so now I want to talk about how you can integrate with Azure Cosmos Tv. So I have a Cosmos Tv account here in my Azure account, and here I'm just looking at the keys. We've got a primary key here and a URI here. This is going to be important in a moment when I actually try to connect to it, but here it is. So the way that we're going to connect to Cosmos DB is through a library called Azure Cosmos Tv Spark, put together by Microsoft and the community. And you can get to it at GitHub. You just search for Asmos or Azure Cosmos Tv Spark. And you'll get here, and then there's a user guide that you can click into and just sort of explore. So to use this within Databricks, we need to download the jar that actually has this library and put it somewhere in your workspace. And then once you've done that, you'll need to attach it to your clusters. That's pretty simple. And remember, anytime you attach a jar to a cluster, if you have a notebook that's currently running on that cluster, you'll have to detach that notebook and then reattach it. But other than that, it's pretty straightforward to add a jar to a notebook. So since I have this already attached, I can go to my notebook and go here. And this notebook is actually in Scala. And so what I can do here is just some imports really quick, and those are going to be helpful. And so then how I actually connect to Cosmos DB just directly is I just do the typical spark.read syntax here with Cosmos DB, and in order to correctly connect to my Cosmos DB instance, I need to put in some configuration items. So here's that that endpoint URL that we saw a moment ago in the Azure UI, and the key. And then Cosmos DB has databases and collections. So in my example, it's just this is the database and this is the collection. And I've only my Cosmos DB instance is only in the US East 2 region, so I just put this here. So we can run this and we'll get some data. So here, is create a data frame, and then if we say display, we'll actually evaluate this code and pull that data down. So this is running. All right, so here we're displayed, and you'll see this is the same data from my JDBC integration example. You can see it's got stuff like app and QuickTime. In this case, QuickTime has been converted into just like a big int instead of a timestamp, but it reflects the same data. What you'll also notice is that when we pulled down from Cosmos, it also included a bunch of extra stuff, sort of metadata that Cosmos DB uses internally. And a lot of times we might not actually care about that. We might just care about the data itself. And so the next thing I want to show is actually how to create a Hive table that points to Cosmos DB. And if you do that, you can actually get rid of some of this stuff in the Hive table definition. So if we scroll down to the next cell, once again, we're using SQL syntax to create a Hive table in Databricks, and we're using the class that we just imported, and we're putting in a lot of the same data, the URL endpoint, the master key, and so on and so on. And then I've added this extra thing, query custom, which actually is going to allow us to select only the actual data and none of the Cosmos DB specific metadata. So if we run this, okay, so now our Hive table is created, and then we can run queries against it. And here's our data. And because we had the query custom up here, we're only getting our actual data and none of the Cosmos DB specific metadata. So once again, along with JDBC, we can explain this query here, and we've got a once again, a query plan is kind of a long string. And what you can see here is, once again, we've got a push down filter. So similar to JDBC, we're saying, hey, Cosmos, only give us data where app equals 3. We don't care about any other data. So just send us that data, and that will optimize the network transfer of our data. In this case, we're also actually doing something else. And you can do this in JDBC as well. But here we've actually said, hey, we only want these columns as well. We only want this data. We don't want any of the Cosmos DB metadata. And so Cosmos DB is only going to send us this data, and that also is going to optimize our network transfer. And that's, once again, comes from this query custom option that we put in the Hive table. So that's how you connect to Cosmos DB, and it's pretty straightforward as well. Okay, so the last integration I want to demo is with Azure Data Lake Store. So here I have an instance of Azure Data Lake Store running, and what you see here is the Data Explorer. So it's I've got 2 folders at the root. One is called Data, and it contains some stuff like some Parquet files and whatnot that I'm going to want to access from Databricks. And then I also have this other folder. It doesn't actually have anything in it, but the idea is that I want to be able to prevent Databricks from getting to this folder. And that's possible. So if we go to, if we actually go to the Azure Databricks documentation, what we can do is we can find documentation on how to actually connect Databricks to Azure Data Lake Store. And here's the URL. So how we do that is basically by connecting to the Data Lake Store via OAuth. And to do that, we can follow the instructions here. But before we do that, we first need to create an Active Directory sort of service user to be able to grant that service user permissions to the data lake and use that within Databricks to connect to the data lake. That way we don't have to use any specific actual human users, permissions, and an account to connect. So for instructions on how to create a service user, you can click here. There's a link, and it goes to this page in the Azure documentation, and it's it looks lengthy, but it actually goes pretty quick. Basically, what you're doing is in Azure Active Directory, you're going to create an app registration, and then and there's a process for that, and you'll create you'll have an application ID, and then you'll create a key, and you'll copy this key value, and then we'll use that later. And so if we go back here, what you can see here is, I'm going to scroll down a bit. So here is the details, the actual code that you're going to want to use to both connect to Azure Data Lake Store with the service user that you just created, and then also be able to mount a folder from Azure Data Lake Store into your Databricks. And I'll demo this in practice in a second, but I just want to describe here really quick. This is your application ID that you created when you created an app registration, and then this is that secret key. And then you basically point where in your data lake store you want to point to. And okay, so let's go to the notebook where we're going to do this. So here I've already created an app registration, and I've got an ID and a key. And then also I've got my data lake store instance. And if you go back here, remember it is the data folder that I want to connect to. So here we go. If I run this code, then it'll take a moment. Okay, and now I got an output of true, and that means that I successfully connected. So now what I can do is I can just do the normal spark.read.parquet to read from this folder, which corresponds to this clicks folder, this parquet file right here. And it's mnt-adls, as you see, because that's where I decided to mount this folder within the Databricks file system. So if I run this code, then it should read some of that data. And once again, it's the same sort of click data that I used in my other examples. And like my other examples, we can create a Hive table. This is pretty straightforward because now that I've connected to Azure Data Lake Store, it's treated as just a location on the file system. So on, in this case on DBFS, but if you're used to other non-Databricks Spark environments, kind of be like on connecting to a location on HDFS. So we can run this code and we'll create this table. Okay, so we've created it, and then we can run SQL on that. There we go. And like I've done in other places, we can say, we can run filters, and here we go, we get a nice string. And just like many of the other data stores that we've used, you can actually push down filters right here. We've said, where OS equals to 19, and so it's going to push down those. Now, this is a little bit interesting for those of you who don't know how this works in Parquet. In Parquet, when Spark reaches out and grabs Parquet files, it can actually look into an individual Parquet file and only take chunks out, blocks out. And that can be good or bad, in the context of push down filters. If the filter I'm trying to push down lines up on those block edges or on file edges, then this will actually give us a pretty reasonable performance speed up. But if this, in my case OS, if all the records were OS equals 19 or just kind of randomly scattered across the Parquet files, this isn't really going to give us any benefit because we're still going to have to read most or all of the Parquet data into Spark anyway. So there we go. Now, there's one other thing we need to talk about in regards to this integration. So if we go here, Azure Data Lake Store allows you to grant granular permissions on the folders and files that you have in your Data Lake Store. And so, if we click this access here from Data Explorer, we can go in and we can see, hey, I've got, I'm an owner, I've got permissions, I have super user privileges, but I've also assigned permissions to, this is my app registration, Databricks integration. This is that service account that I use to actually connect to Azure Data Lake Store. And if you recall, I said that I don't want permission. I don't want to grant Databricks permission to read the secret stuff folder. But if you look here on the root folder, I am granting permissions for my service account, read and execute. Now, this is actually important because you need to do this, at least read and execute privileges on the parents of the folder that you actually want to be able to read from, which in my case is data. Otherwise, it won't work. You'll get a permission error, and it might not make sense. So here's this, and then if we go into the data folder itself, and we go to access, once again we have Databricks integration. Now read, write, and execute. And if we wanted to add, if we had a folder that in Data Lake Store that we want to add permissions to, what you can do is go to add, and then you gotta go into Databricks, and here we go. Here's the same service account. And what you would do is click all these, this folder and all children, so that we can assign access to data. And then this is a little bit interesting. An access permission entry basically means, hey, you have access to this file or this folder or whatever. A default permission entry is more like, hey, any new folders or files that get created here, you're also going to have access to those. And so when I created it for the data folder initially, I just put an access permission and a default permission entry. That way, anything that was in there already, I would grant access to. And then if anything got created in there, I would also get access to that. So I'm not going to do that because I'm not going to click OK because I already did. But that's how you would go about this. So, and that's how you connect Databricks to ADLS. All right, thanks for watching this brief introduction to how to connect Databricks to the bigger Azure ecosystem. I've only shown a small slice of what's possible, due to time constraints. If you guys are interested in this, there's also a ton more you can do with Databricks within Azure, including, for instance, connecting Power BI and other BI tools to Databricks to be able to run basically Spark SQL queries against any of the data that Databricks has available to it. And then also on the streaming side, which I didn't really get to today, you can connect Databricks to Event Hubs and IoT Hub within Azure to run data analytics against streaming and IoT data, which is pretty cool. So thanks everyone for watching this, and have a good day.